For the last session, we invite on stage Professor Shailja Singh, Scientist, Special Center for Molecular Medicine, JNU, Professor Anand Ranganathan, Scientist, Special Center for Molecular Medicine, JNU, author and political commentator, to make their presentations on mRNA malaria vaccine, learning from COVID-19.
Good morning, everyone. So again, a great pleasure to be on the platform of PLF and talking about things that we really love. It's again a pleasure to be a colleague, a friend and a collaborator of Professor Shailja Singh, an absolute eminent parasitologist and someone who's worked in malaria, the field of malaria and parasitology for more than 30 years. I thought for the next 35 minutes before Gloria starts to do her glorious dance with the bell, we'll talk about something that has come up in the last, I would say, 4 years with a real bang and prominence, something that was in the background for more than 25 to 30 years. And what brought that into prominence was the pandemic. Where do we go from there? Where do we see the future of us tackling pandemics? And I don't want to, as the title, if I can remember, it's not there, the lessons from the pandemic. So we won't be emphasizing or focusing entirely on COVID, but we will use that as a starting place to go beyond COVID and to look at the kind of diseases that afflict Indians that the rest of the world is possibly not as bothered to cure as the diseases that afflict them, especially Western nations. And I think there are a few points that, Shailja, we can start off with before we come to the specifics of mRNA vaccines and their future. So the first one is the obvious one. All of us remember December 2019, November 2019, and the journalists amongst you and Shiv, of course, I remember his tweet about the Wuhan thing. I think it was November, if I'm not mistaken, when the real thing started. So the story kind of was like a tumbleweed in the later months of 2019, but then it exploded when WHO said that the virus is not transmitted, to humans. That's their iconic tweet. And I remember Shiv was one of the first ones who quote-tweeted that tweet. I think he called WHO as Wuhan Health Organization. But then it reached it kind of, pierced the public consciousness. Before that, it was just another virus amongst thousands of viruses that, wreak havoc sometimes not, afflict humans. You remember a couple of months ago, there was this monkeypox thing. Some news associations with diseases catch on and some don't. But that's the news part of it. The other part of it is the science part. Yes. And I think that's equally important, because it's not just that people thought, look, COVID story is important and it should gain prominence. It was the science and the devastation behind it that actually led to the entire news. And people now know, yes, yesterday we were talking that, I think it was Mudit who asked the question that what is the perception of science in the common citizen now, and I think it's increased enormously because of COVID. Now we know what RT-PCR is, now we know what a virus is, now we know what a coronavirus is and what a pandemic is, so many other things. Treatment, vaccines, mRNA vaccine, other vaccines. So many things did not work. Everything was tried for COVID. So we know what things to try, plasma, so many things. But it all started in 2020. Let's put that mark as Jan of 2020. How prepared were we? We were not prepared at all. Absolutely not. And why? That's the next question. is because we were so lazy and callous when the first pandemic struck us. That's before the social media age. There was no Twitter. I think there was no Facebook also. 2003, 2002, I think, when SARS-1 struck. Now, it did cause devastation, of course, to a very limited extent, not compared to SARS-2, as we know. And a lot of governments immediately gave grants to scientists and to pharma companies to make vaccines against it. But before the vaccines could be put to clinical trials, the virus went away. The virus disappeared, and lo and behold, as we trust our governments, the grants also disappeared. You know, the politicians said, "Arey bhai, virus nahi hai, vaccine bana ke kya karoge? Hatao isko." We know a couple of colleagues, in fact, one in JNU who got the vaccine grant, वो suddenly कर नहीं बस अब किसी और में डाल दो इसको. अच्छा, TV पे काम कर रहे हो, चलो वो कर लो, SARS की. Had we made a vaccine against SARS-1, we would have saved millions of lives in the first phase of SARS-2. Because the spike protein of both SARS-1 and SARS-2 are very similar, portions of them identical. And the vaccine that would have obviously killed SARS or not allowed SARS-1 to gain infection would have helped a lot in preventing the kind of spread of SARS-2 that we did in the initial month, even going forward a year. So that's the first lesson. Do not stop funding, do not stop doing science just because the pandemic has disappeared. Because the pandemic never disappears. And right now, if we believe that we will never have another pandemic, we could not be more wrong. There is SARS-3, there will be SARS-4. The question is our preparedness. We did not have a single vaccine going into COVID-19. We didn't have a single drug against it. We tried hundreds. Both of us tried one. We were asked to get a grant for that. And we didn't get a grant. And then what happened, after a month, it turned out there was a Lancet paper, and the drug that we had proposed repurposing against COVID, it said it works spectacularly against COVID.
From French?
From French scientists, yes. The bottom line is, we were not prepared. So going forward, we have a vaccine against SARS-2 now, right? Will it work against SARS-3? That's the question. Of course, it will not work perfectly against SARS-3 because it doesn't work sometimes at all against even SARS-2 later mutants. The vaccine that was made against the original SARS virus is hopeless against Omicron, you know. So even the variant of the same virus, the vaccine is ineffective. The point being, at least you can have a stopgap arrangement, but at least we know how to tackle SARS-2. We have a few drugs that can work to a limited extent. Most drugs did not work. I think remdesivir is the one that actually worked to a largest extent. Otherwise, so many others. Even Musk jumped in and said chloroquine is working, and then he said, you know, so many. I think the other drug that he named was against river blindness. Ivermectin is working. The question is, going forward, do we need a vaccine? The answer is yes. Now, how do we go about making a vaccine against every disease? It's not a question of a vaccine against a pandemic. It's not a question of a vaccine against a pathogen that is causing a disease. The lesson that we need to learn is we need to make a vaccine against every possible pathogen that will create a pandemic. Even if there is no situation or scenario of a pandemic happening against that pandemic. We just need that. That is what preparedness means. So going forward, before we delve on to the other things, I think, Shailja, it would be wonderful if you can give a nice background as to what is a vaccine and how does it work and why do we need a vaccine as opposed to a drug?
Yeah, so thank you, Anand. It's a nice introduction why we need a vaccine. Yeah, is it okay now? Yeah. So, yeah. So to start with, like when we already have disease, of course we treat them with the help of drugs and other things. But we want to prevent happening the disease. That time vaccine comes into picture because we just don't want the disease, what is around us. So in that case, to have the protection, the vaccine works. And how it works? Because basically your immune system, which is there in your body, you are training them to remember this is a pathogen which will cause the disease. So once your body is trained to detect the pathogen which is going to enter into your body, you are already prepared. The immune system of your body is prepared. So in that case, memory is there in your immune system. As soon as the pathogen or any per se disease causing element is entered in your body, your immune system has a check. It will detect and also clear it. So detection as well as clearance is being done by the immune system. How will you train your immune system? Because your immune system has not seen the pathogen yet. So you are providing the information in terms of DNA, RNA, protein, about the information about the pathogen to your body, and that's called the vaccine. So vaccination is that your immune system is now able to recognize and clean it from your system. So in that case, as already there could be many ways of making vaccine. For example, as we know, for SARS coronavirus, we have two types of vaccine majority. Like we can have the whole pathogen, we can weaken it, we can kill it. So the pathogen is in actual form and you are just killing with some chemical inhibitors, you are killing them for irradiation, you are weakening it through some molecular biology, and that pathogen you are injecting to human body. Now it is not causing the disease, but your immune system now knows, okay, this is the pathogen, I need to be prepared myself. Second is that you don't need to have the whole organism, but you can have information from the organism, information from the pathogen. So what is the information? The information is the coding in that pathogen, which is there in its DNA or its genetic material like RNA. So in that case, you dig the information in the form of DNA sequence or in the form of RNA sequence. Or you just want, okay, no need to do that. You have the information, make the protein, give the protein, which is a subunit vaccine. So like a very, very known vaccine, polio vaccine. It's a whole cell vaccine. The virus being killed and given orally. So your immune system is trained. There are subunit vaccine where you are giving the protein and then you are challenging your body to recognize. Now comes the mRNA vaccine. Why the mRNA vaccine is good and why we need it? First of all, of course, there are some challenges involved in the mRNA vaccine, but at the same time, it's faster because you are just taking the sequence from the pathogen, putting it into the human body. And your body is making the protein out of that information, and your immune system is being challenged by that protein, and you are ready with whatever pathogen come.
Just to add a little bit for a background, so the dogma of life works that you have DNA, that's through your chromosomes. The DNA is coded and it's decoded into an RNA, and the RNA is then decoded into a protein, and the proteins are the ones that run your cell and everything. So DNA, RNA, protein.
Central dogma
of life. The DNA is in the nucleus. The RNA that is made escapes from the nucleus of the cell, goes outside but into the cytoplasm of the cell, and that RNA is then worked upon by ribosomes and other translated into protein. So the mRNA or the RNA is floating around in the cytoplasm and proteins are made through there. So the mRNA vaccine,
So yes, but I was just talking about the mRNA vaccine. It's not that easy. You know, the Nobel Prize 2023 Nobel Prize gone to Catalina and Wiseman. What they did, they just told that whatever mRNA or DNA you are making, which we call the nucleotide, which is a building block of that mRNA, even it can be seen as a foreign in your body. Let's say I'm just putting an information to a human body, but the information is something which you required, but even the delivery method you are seeing as a foreign.
So here again, I'm like an inquisitive child. I speak for the audience.
Yes,
because it's
please.
very interesting. Each question comes and it cascades into another question. Now, our human cell is so fiendishly clever. Otherwise, any virus, an RNA virus or something like that, would inject your RNA into the cell and nothing would happen.
Yeah.
But our cell sees that even RNA as foreign and destroys it. So if you were to make an mRNA vaccine, you are injecting a foreign RNA, your body would destroy it. So the vaccine would not work.
Yeah.
No.
Yes. So in that case, even the vaccine, you have to humanize it. Meaning it should look to your body as your own, because information is there. And there comes the Nobel Prize work by these two scientists. What they did, they just modified the mRNA. Why they modified? They wanted this sequence of mRNA to be recognized as a self. And then second thing, they also wanted it to be stable, because as soon as you are going to put the mRNA in the human body, and I will just degrade it. So in that case, it is not going to help you. Third thing, even your immune system should not be provoked by that mRNA. And the fourth thing, the information should be properly translated. As he just said, from DNA to RNA, RNA to protein. If the RNA is not going to make protein, it is not going to work. So in that case, all the 3 points being taken care by the two Nobel laureates, where they could modify the mRNA. So you can see in this picture, where if you are putting just the mRNA vaccine, which is a unmodified form, it will just go and it will be degraded, one thing. And even the body of a human will see it as a foreign, and then it will evoke some unnecessary immune response. But in case of their discovery, they made some changes into the mRNA, and that mRNA is now recognized as a self. It will do its job properly. It will translate to the protein, and it will also evoke a very specific immune response which is required, like against the SARS coronavirus. And in our case, now we are trying to put the sequence for the malaria. So, yeah.
Can you go to the first slide, please? Yeah. So now that we know that we were unprepared, not just underprepared, unprepared for the pandemic, and how do we prepare ourselves? We need a vaccine against a pathogen. What kind of vaccines there are, Shailja has already told you. What is the easiest and fastest way to make a vaccine? Yes, mRNA is one, heat killed is another. The next question I want to talk about is important, and it's political, and I have deliberately added that thing, India, a world vaccine hub, because in the time before podcasts and videos, I used to write articles every week. And I figured out very quickly that if I write an article that has Modi, 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 it will have 700 comments. If I say Modi, Rahul Kejriwal, Modi, Rahul Kejriwal, will 500 comments. If I spend half a month and write an article of 6,000 words describing something scientific, it will have 2 comments. One of them would be my reply to one comment. So I just added this to kind of, tickle your curiosity and maybe get more audience in. No, but to be serious, we've always prided ourselves as India is a world vaccine hub. You know that. Are we? That's the question. And that's answered by facts. What are the facts? On 12th of January 2020, China made public the SARS-CoV-2 genome, right? 12th of Jan. On 13th of Jan, Moderna applied for clinical trials for their vaccine. 24 hours. Did we ever call USA as a vaccine hub? No. Within 2 weeks, on 24th Jan, Australia cultured the coronavirus. A week after that, end of Jan, CDC Atlanta cultured the virus. We took 2.5 months to culture the virus. At Pune, it was done, NIV. We took another couple of months to hand over that cultured virus to Bharat Biotech so that they could inactivate it using so chemical inactivation, beta-propiolactone, and make co-vaccine. We were not the vaccine hub. We lost 4 to 5 months. And we didn't see it then because nobody knew how COVID is going to act upon the world. But we knew very soon the next year when the Delta wave struck. We knew that those 3-4 months that we lost, had we administered vaccines to the scale and quantity that we started doing beyond the Delta wave or during the Delta wave, we could have saved tens of thousands of lives, Because Delta wave was not just devastating because it was killing. It was maiming, it was killing, and there are people in the audience who suffered, and my brother Vikram Sampath was on a ventilator during the Delta wave. It was just unbelievable. Each person vaccinated meant one oxygen cylinder less. It just came down to that. And we lost 4 or 5 months. And it's not just the Covaxine. The Covishield that had an adenovirus backbone. For 10-15 years, Indian scientists were using that same backbone to make rabies vaccine. For malaria vaccine they were using, We did not think of using that backbone for SARS coronavirus. It was the Oxford scientists who did it. And they then sold that technology to AstraZeneca. That was then outsourced to Serum Institute that then mass produced it. The point I'm trying to make is, let's not just call ourselves, anoint ourselves as something that we're not. Let's aspire to be that first. I hope that's a big lesson. You don't become a world vaccine hub when you are 3 months late or 4 months late, even beyond what Australia achieved within a couple of weeks, what America achieved within 24 hours. That's the point. So, having talked about that, the next point is, what is the past, present and future of mRNA vaccines? And let me couple that with lessons from COVID. And can this be deployed against malaria? Shailja has already talked about the limitations of mRNA vaccines, that before COVID, the mRNA vaccine field was undergoing huge R&D for 30 years. But let's be honest, there was no RNA vaccine on the horizon. It was only COVID that brought that to the future. She talked about the modification that allowed one to do it, escape our immune system, so that the mRNA would at least be able to make a protein against which we wanted our immune system to act. So we want a foreign body, as soon as it enters the cell, our body to react to it. But we want the protein as a foreign body, not the mRNA, because if the mRNA is acted upon, then you won't get the protein that you want the body to act upon. So, Shailja, if you'd like to take forward mRNA vaccines, past, present and future, and then specifically deploying it for malaria. Next slide, please. Thank you.
So, so just want to give one information, like when Kathleen, she was trying to modify the mRNA, and she put up a project which later led to a Nobel Prize for her, and that project was denied. So she did not have money even to work on that mRNA modification, because nobody understood the value of that mRNA modification. So that's what the past mRNA research was that way, not taken very seriously. But as COVID struck and as well as some other diseases, now we understood if we really need a faster way of dealing with any disease in the form of vaccine, we need this technology. And that's the present scenario where everybody now wants to use mRNA vaccine platform for they are working in that disease. For example, I work on malaria. I just want to use this technology to develop the mRNA vaccine. Similarly, let's say somebody working in some other diseases, even the cancer, they also want to develop the mRNA vaccine for the cancer. So that became really very, very important. And the future, what is the real future of this mRNA? So malaria vaccine is like, since we all know that the parasite is living us with millions of years in the host, that is mosquito, but in human it is living with us by 10,000 years. So the parasite, which is a malaria parasite, which afflicts the disease malaria, that is already in a symbiotic relation with human. And it has really understood that no need to be so hostile. If I'll be hostile, human body is going to throw me out. So the cleverness of the parasite we need to understand. So in that case, we need to understand, okay, the vaccine approach, how it should be that, yes, we should recognize that region which is been...
Sorry to interrupt, Shailja, but is that connected to the thought that many people would have, that I also had, that malaria was, I mean, the parasite was discovered more than 100 years ago. Why is it that we don't have a vaccine?
Yeah.
Or
So-
we have now, recently a vaccine, RTSS, that efficacy is
Very poor.
42%. You know?
Yeah, very poor. So as I said, the parasite is too clever. If you are making a subunit vaccine, you will use information in the form of protein from malaria parasite. It will just change in one month. So parasite is continuously changing the structure of its protein, because it doesn't want you to...
So is it a bit like the coronavirus that...
yeah, similar.
So the vaccine that was made against the first original
Wuhan
one
virus,
is not...
then Delta, then Omicron, every time it's changing. And you can see so fast, malaria parasite being with human in 100 years, it is every day, everywhere, it's changing the protein. So in that case, it make a difficult task for the scientists to come up with a vaccine against malaria. So with that information, I think people have tried even the wholesale vaccine, like they dissected the mosquito, take out the parasite, and then you can imagine how many mosquito being dissected and parasites is being taken out and bottled to have a malaria vaccine.
How many?
Like in one mosquito we get 10,000 parasite in the salivary gland of mosquito. So like 10,000 people sitting and just dissecting the mosquito, taking out the sporozoid, bottling it, it's not possible. But then also we tried because we want to save life, right? So that's the sporozoid vaccine, the whole cell sporozoid vaccine. Then we improved our technology. We came up with the subunit vaccine, and that subunit vaccine is the RTSS, which you said, and it has only 42 or 45% efficacy. So we also have not progressed. Now comes the mRNA vaccine. Why mRNA vaccine is quite important? Because it also gives you the flexibility. Parasite is changing its protein, no problem. Give the whole length of protein. You can increase the length of mRNA, which is not possible in case of subunit vaccine. So this is advantage. And with the Cataline and the other discovery, we can also find out the modification is fine. And the delivery of the mRNA is quite easy now. So with all these information, I think this is a real good hope that we should have now the mRNA vaccine for malaria. And we should also, but at the same time, as I said, that malaria is not just one type of malaria. We have 5 parasites which cause human malaria: Vivax, Falciparum, ovale, malaria, and one is the monkey malaria, which is coming from the monkey and now affecting the
Why
human.
are you pointing at me?
Yes, coming from the monkey. So we also need, we have to deal with the 5 parasite which affects the human. So the vaccine should be that efficacious, not only one parasite, but it should also protect against all the 5 parasites.
For example, in India, most of the malaria occurs through Falciparum or Vivax, or
Yeah,
in
so
Africa?
we have both,
Vivax
and Falciparum. Africa has only Falciparum.
Okay.
And now we have co-infection, malaria and Vivax both. We have another infection, malaria, which has is continuous throughout the year. It affects your mostly spleen and other organs. So this is the problem.
Right. Can we have the next slide, please? Thank you. Yeah, the next. Yeah.
So these are some technical things. How will you make the mRNA for the students? And
So tell us a little bit about, because you started making these mRNA vaccines.
We have
three things in there.
Yeah.
One is the delivery, because that was the thing that actually a lot of people said that, look, America has that cold chain, that you have the mRNA vaccine and you require -18, some said -70 degrees, and they have the cold chain. India is just not feasible to have that. So in India, you're making an mRNA vaccine, that too against malaria. So you're going to go to poor regions of the country. You won't have a cold chain. what is the solution that you have to kind of remove that obstacle? Second is that, as you talked about, you can have a vaccine that works against falciparum, but in an endemic area that is affected primarily by Vivax, would it be that that vaccine doesn't work there? I'm not just talking about different continents where the vaccine might not work. That's the second point. And the third point is, for example, if you find that the mRNA that you give is simply not enough for you to make the protein, this thing about self-amplifying. So 3 questions in one.
Yes, okay. So I will just take the self-replicating first, because the mRNA vaccine, whatever we are making, if you inject at 1 dose and it will be degraded, it's not, you want a system where, like a self-sustainable model. So you not only you are giving the mRNA vaccine to a human body, but you want human body to replicate it. So you don't require to give more dose. So only 1 dose of mRNA vaccine. So there comes the self-replicating. The vaccine itself is replicating itself, and it is giving you protection. So that is one thing. And second, the cold chain problem.
So just to continue on that, is that how safe is that you will continue to generate that mRNA inside your cell?
Yeah. So in that case, we know that pathogen, whenever they enter, they also replicate. But the self-replicating plasmids, which has the mRNA vaccine, it's not that like lifelong it is going to be replicating. The system is that it will replicate, the machinery will only support its application to a certain period of the time. It's just not the lifelong you are making the pathogen protein. So that is being taken care of very well from the scientific community, and the technology is in place. Second point is the cold chain. Yes, I do agree. Being in a tropical area, as well as the humans are living to the very far area, in being a big country like India, we have a problem of transportation of vaccine having the cold chain, and I think there comes the need is the mother of invention, and we do aware of this need. That our vaccine system should just reach in a normal cold temperature, not a deep freezer type of a temperature. So being a scientist, we have delivered a delivery system where we will put our mRNA and that will be stable. And you are part of that research, Anand. Yes. So we are making some kind of a bags, the very, very smaller bags that is coming from the human cell only. So again, human body will not see it as a foreign, and which is very stable. And we are putting the mRNA inside the small, tiny bags of human cells, and that we are going to deliver. So very soon we will come up with the patent as well as the publication. So that is the solution I would like to give. And the third thing is that, as you just pointed out, that we are suffering not only for falciparum but Vivax, as well as some other 2 strain, malaria and oval. So of course we are looking for some proteins which are very common between all the 5. So if we want to give one protein for all the 5 strain, which will affect human and cause malaria. Along with that, like it's just to make you all understand, the parasite is like it shuttles between the human and the mosquito. You get the mosquito bite, parasite comes to your body, it goes to liver, from liver it goes to your blood, and there it also commits some sexual commitment, and it makes a male and female gametocyte. Then mosquito again picks your blood, and there it goes, the second cycle, which is a primary cycle, goes in mosquito. So if you want to really have a vaccine, you just want a vaccine not only between the strain, Vivax and falciparum, but between the stages of malaria parasite which is there in your body. Liver stage, blood stage, sexual stage, all the 3 stages of parasite. So you have to identify the proteins which are there in the liver stage, blood stage and the sexual stage, and all 3 combined in a mRNA vaccine form. So you will not only prevent the disease, but you will also prevent the transmission. Because if I have a good immune system and my parasite is been taken care of, but in my body there are sexual stage malaria parasite, mosquito will pick and another individual will get affected. So all the 3 stages of malaria parasite we are trying to combine, along with that the proteins which are present in all the strains.
So the transmission stage would be
Multi-stage.
acted upon that the mosquito will suck your blood,
Yeah.
and the antibody against a mosquito protein will go inside the mosquito.
Antibody against the parasite protein.
Against the parasite, I beg your pardon.
Will go to mosquito.
Yes, will go to the mosquito, and the mosquito will not be able to process the parasite as it normally does.
Yes, yes, because in parasite cycle, in the mosquito will stop.
Right, right.
Yeah.
And is an alternative also, rather than looking for one protein that is common to all strains, could you have an mRNA cocktail? Let's say if you have an mRNA that is for a protein specific to falciparum, you mix it with an mRNA that is specific for a protein of vivax or some other thing. So 5 or 6 mRNAs. I mean, what's stopping that?
Yeah, I don't believe in cocktails. I want a single solution. So I'll put all genes in one cassette. Because that way I don't know which mRNA is delivered better. In a cocktail, amount of particular protein is more or less. In a molecular biology, the ratio becomes very important. And its expression also become very important. So if I am going to put 5 members together, I don't know whether one member majoritarian or minority one will be suppressed. I don't want that. Everything should express in one go.
Wonderful. We have 10 minutes, I think? Yes. 5 minutes, all right. It's never 10, it's always 5 with Gloria. 6 minutes. Before, and I myself want to ask one question. No.
You are not allowed.
No, I think because that's going on in the minds of the audience.
I'm sorry.
No, of course. When it comes to mRNA vaccine, which is just one word, safety. We've heard for the last 3-4 years about the safety, not the efficacy. The efficacy, of course, changed, and there's so much misinformation, and Musk himself has spread that misinformation. When you say, when he talks about, those bites of the Pfizer vaccine has an efficacy of 99%. Then in that video, by the end, it says it's 50%. Well, that's because the strains are changing. So that's scientific. It's not that the same vaccine that was made against the original strain will have 99% efficacy against Omicron. And if that doesn't happen, it's not a remark on the failure of science. It's just the success of the strain, that it's evolved and mutated. So the vaccine is beyond that, not the efficacy. I'm talking about the safety aspect of it. Do you believe that all the controversy that has surrounded the mRNA COVID vaccine will get carried over for the mRNA vaccine against malaria?
Yeah, at the level of approval, I feel, because this is already spread and mRNA vaccine not that safe. So of course, whoever is going to develop the mRNA vaccine for other disease, they are going to face a difficulty at the point of approval. Though they will do all sorts of experiments and the evidences that this is a safe. And personal level, I believe that the data which says that the mRNA vaccine is not safe, it's very insignificant statistically. So to conclude that, I think we need more information. However, I am well aware that the mRNA vaccine, if at all we will be successfully making it, we will be going to face the difficulty, and there we will need you, Anand.
Thank you very much, Shailja. It's very informative. I think we have questions.
I have a question.
Yeah.
In fact, Anand,
as an organizer, you're not supposed to ask.
You asked my question.
This is my, and plus you have a conflict of interest. You're Gloria's sister. There's 2 conflict of interest there.
Very quickly.
Just joking.
I'm asking on behalf of everyone who is very curious. With regard to, first of all, you asked my question, so thank you for that. Second, so I have a second question.
Yeah.
With regard to the virus, what we were told, especially when Omicron came, and that our vaccines were not working, was that with every mutation, the virus gets weaker.
Yes.
Okay, so therefore it was not really serious whether we got the Omicron or not. Even, I think Govardhan Das also said it's not even serious. But what
He went to the extent of saying that Omicron
Is a
is a vaccine.
Is a vaccine.
So now when it comes to explain to us the creature that is the parasite, does it not get weaker in time? 100 years, like why has it not got weaker?
See, parasite and virus has two difference. The parasite is symbiotic. Yeah, and virus is hostile. Parasite wants human to be proper, and it tries to adopt in such a way it should not harm, it should not be that hostile. So that's what it doesn't get weaker, rather it become more stronger and stronger in terms of being adopting towards the situation. And that's what the problem is to tackling that parasite, which is already there in the body, living nicely, and it afflicts the disease.
Professor Singh, I have a question.
Yes.
What do you think? What are the ethical consideration may arise while testing or deploying those vaccines? To with the population which have historically been subject to medical research, and how do you think this can be navigated responsibly? Yeah. Thank you.
Yeah. So the major problem we will face is we don't want anything problematic to our genes, our genetic material, because whenever we use any genetic material information like a DNA, RNA, we are very afraid maybe it will go and integrate to the genome of human, right? So this nobody likes it. So the problem which I feel is the major problem, DNA vaccine I don't think any time will be getting approval, because you are just putting a DNA, and DNA can just integrate, and so that way. But mRNA will never integrate to the genetic material of human, which is a DNA, not mRNA. But the problem with the mRNA, as I said, the delivery of the mRNA, if we are making self-replicating mRNA, or if I am putting in a viral cassette which contains the DNA, and that mRNA coding genes are being integrated to the viral genome, that may cause a problem, right? So that is.
So in fact, that's a great question, because does that mean that self-replicating machinery is more dangerous in that sense than just injecting mRNA? Because mRNA would never go to the nucleus, obviously, and it would obviously never integrate into our genome. But the self-replicating machinery is actually DNA that is coding for the mRNA that's making. So the DNA might, I'm just saying.
I agree, but कितना dose दोगे? Dose का भी requirement है. You can't just give a bulk of mRNA to a human body. It has to be some sustainable model. Right now I am proposing self-replicating mRNA, but of course with time, with more technology advancement, we might have some degradation procedure. So we'll ask them to replicate and then degrade it. So that machinery can also be tailored together. So just make that way that the DNA will replicate for, let's say, some time, then put a switch on, it will degrade.
Can I have a quick show of hands here? So the two type of vaccines that we discussed, just two. One was mRNA vaccine, and the other was heat inactivated vaccine like polio or others, the traditional way. Show of hands, how many of you prefer the heat inactivated vaccine to mRNA vaccine?
Heat inactivated, for me as well. Yeah.
Okay, so the majority wants to be
heat inactivated.
Yeah.
So we are also working on that, Anand.
Yes.
But of course, sometime you need a speed.
Thank you very much.